Okay, good morning all. We're on to our grade 10 mathematics, arithmetic it is, and we're on to the Mambo experience. We're going to, within a short time, try to clear out our understanding on use of logarithm tables to handle problems relating to logarithm. We've gotten lots of ideas, and now what we're going to do using exercise 1L of our New General Mathematics Book 1, and that should be on page 27 of our textbook, will be to combine different ideas and see how we put them together in solving problems. Take note of this. The way I'm going to solve this may not be the same way another student or teacher would solve this. But like I always make it a policy when I solve problems, I try as much as possible to be as quick as possible and to use every aspect of my mind. I try to call back every topic I have studied in attempting the problem. So let's see how this plays out. Now, if you look at this, what you have here is 17.2 squared times 4.93. These two form what is called the numerator aspect of the problem. For what is called the numerator aspect of the problem. You may not be seeing my face, but just ensure that you are keeping up to date with what's on the board. Now, your first start, we've said that your understanding of logarithm is built on the concept of your standard form. So you need to look at 17.2 and try to imagine what it will be in standard form. So 17.2 would be 1.7 times 10 raised to the power of 1. Why? We had said that the concept of standard form is to write a number as a unit with decimal parts times 10 raised to the power of the movement you have made. If I move one step backwards, I would have made this big number to be small. So hence, the power here would be what? Positive. So that's why you have this to be 1 point. Because this part is actually 1. Now, I'll come to this one. This is 4.93. It's already a unit decimal. So this will become what? 0 point. No movement is made. No movement is made. The number is a unit decimal. That will be 0 points. What I do next is to use my logarithm table to find 17 under 2. What would that give us? 2 what? 2 what? 2355. 2355. Right. Sorry about that. Let's reduce that. 2355 times 2. Why is it times 2? Anytime you see a power with a base number, a reference number, when you are working that in logarithm, it will mean multiply whatever you get by 2. Now, when you multiply with 2, you transfer your answer this way, and that will give you 2.471. Am I right? 0. Is that correct? Yes. 2.4710. Please confirm that. And then this will give you what? 49 under 3 will give you what? 6928. You transfer this way to 0.6928. Now, because the numbers here are being multiplied, you would add them up. Whether you put the sign of addition or not, it makes no difference to us because we already know what you're doing as a function of the question given to you. So this will give me what? 8, 3, 6, 1, and 3. So that will give me 3.1638. Alright, so that's for my numerator part. Now, my denominator has this. So what do I do here? Look at this. If I have this, and I write the unit decimal, this will be 6.75 times what? How many movements am I making to get this? 1, 2, 3, 4, 5, 6. I am trying to compress a very big number by 6 steps, and that will be positive steps. So that will give me 6 points. I'll go to my 4-figure table and check 67 under 5. What does that give me? 67 under 5. So that will give us 8293. But recall that we have a cube root sign here, is that not? So what that means is that divide this by 3. Whatever you get here, transfer it here. So I'll rule this. So this will give me 3 divided 6 will give me 2 points. 3 divided 8 will give me 2. A carry of what? 2 into 21, 7. Into 19, 8. Into 19, 6, sorry. A carry of 1 into 4. So that will give me 2.2764. So this is what we're going to get. Now, what is connecting numerator and denominator is what? Subtraction. So you're going to subtract this from this, or you say this minus this. So 8 minus 4 will give me 4. 3 minus 6 is not possible, so I'll take 1 from here. So that will give me 7. I take 1 from here. 15 minus 7, that will be 8. I take 1 from here. 10 minus 2, that will give me what? 8 again, and that will be 0.8874. At this point, I will go to my anti-log table. So I'll write here anti-log what? Equal to whatever I'm going to get times 10 raised to the power of what? 0, because this digit is what? 0. So let's check that. It is 8 under 7 difference 4. Now, so what do you have? 7.703 times 10 raised to the power of 0. So the final answer becomes 7.703. That will be the final answer and solution to this problem. And we have solved it. 7716. 7716. And that is 7.709 plus, what's the difference? 7, is that not? Difference 4 is 7, so that will be 617.7. Alright, so that clears out that problem. Okay, looking at question 50 of this exercise, we have a question up there, 38.32 times 2.964 divided by 8.637 times 6.285, all raised to the power of 2, finding the cube root of this number. When you look at the question, it looks like a very, very complex question to solve. But it's one of those questions we say are what? Big for nothing. We'll just start by applying a little idea from our indices. If you look at this, we know that when you see root, it means what? 1 over. So I can rewrite this problem to be this. Watch me. Or raised to the power of 2. This cube root means 1 over 3. All over 3. So this problem is this. Or raised to the power of what? 2 over 3. That's it. So you discover that all the ideas you have acquired in maths, if you apply them well here, you discover that this problem is not going to be very difficult for you to handle. The next thing you take note of now is to try to break it down into what? Number, log, and our third column. So I'll take the numerator part first. That will be what? 38.32 and what? 2.964. I'll call that numerator. And then the next thing I'll do, I'll take care of my denominator, which is what? 8.637. And I also have 6.285. And that will be my denominator. Whatever I get from this, I'm going to treat here as my final answer. Whatever I get, I'm going to treat on this column to get my final answer, and then I'll get my anti-log out times whatever it is. So this is just the setup for the problem, and then let's go into it now and try to take note of what we need to do. Now, look at this. This is 38.32. To make this a unit decimal, I move this backwards. So this one becomes what? 1 point. This is a unit decimal. This is a unit decimal. This is a unit decimal. So you see, I've solved part of the problem. The next thing you do is to now check what is 38 under 3 difference 2? What is 29 under 6 difference 4? What is 86 under 3 difference 7? And what is 62 under 8 difference 5? Once you plug in these values, you treat this to get this answer. Because you're multiplying these two, you add them, you get an answer here, add, you get an answer there. Once you've done that, you transfer the answers here, work on them, and then get them and bring them out this way. Okay, for want of convenience, we've tried to use our logarithmic tables to get out these different values. 38 under 3 difference 2 will give us this value. 5834, 29 under 6 difference 4 will give us this value. 4719, 86 under 3 difference 7 will give us 9364, and 62 under 8 difference 5 will give us 7983. We'll then transfer these values here. So we'll add these two values, you're going to get 3, 4, 5, 0, and 2. A carry of 1 this way. Now we add these two, you're going to get 7, 4, a carry of 1, 3, 7 again, point what? 1, is that not? So the next thing we do is to subtract these two. We're going to do what? Subtract. But what I added at this point is that we'll need to transfer the answers this way. You're going to see why we need to transfer the answers this way. It's just for purpose of clarity. And then we'll do our subtraction here. You see, it's clearer when I'm doing my subtraction here. I'm going to get, what do you have there? 6, 0, 2, I'm right with that. 3. So that's 0.3206. Remember that whatever we have gotten here must be multiplied by what? 2 over 3. So I will come here and now say what? Times 2 over 3. So I will come this way and do the computation. That will be 0.3203306 times what? 2 divided by 3. Now, you multiply this, it will give me what? 0.6, that will be, last digit will be 2, 1, that will be 4. So that will be 0.6412, and then I divide by 3, and that will give me what? 0.2, 1, 3, 7. Now there's supposed to be an invisible 1 here into 0, so it's not up to 5, so we can do what? Ignore it. So our answer becomes what? Whatever I get here, I'll transfer to this point. 0.2137. This is what I'm now going to use to look for my anti-log. So I'm going to my anti-log table now, check 21, under 3 difference 7. So that will be 1.636, that times 10 to the power of 0. Where am I getting this 0 from? It is from this part. Whatever this value is what this one is raised to. So finally, your answer becomes 1.636. You discover that the problem was just big for nothing. And you can see that we've been able to crush it. So this will be the concluding aspect of this log problem. We'll be coming back to logarithm again, but then we'll be dealing with things that borders around bar notations and how to handle negative standard forms. So we're going to call it a day on this aspect and trust that you have really enjoyed yourself. All right, see you soon.